So here today I'll be explaining the Huffman encoding. Um, Pretty much going to be adding different sample um, codes into a template that was made before. So just gonna explain that as well as just basic meaning of what Huffman encoding is. So Huffman encoding is a lossless compression method, and it allows original data to be perfectly reconstructed from the compressed data. So in a sense, we use this for like zip files, gzips, and etc. etc. Pretty much just a way of compressing stuff, um, or a method uh, per se. So first of all, I am going to explain pretty much this whole segment of code here. Pretty much what it does, why this is commented out, pretty much, and yeah, it's just gonna be that. So pretty much, we have here is include iStream, queue, unordered map, and string, and regular basic stuff here. Libraries per se. This is pretty much necessary so you can declare all the stuff we need here, like standard namespace, use standard library features, and iris stream for input output, the queue for priority queues, unordered map for hash maps, and the string for string manipulation in the code. So we're gonna start off here with the with the node structure here. We have car data character that is being stored uh, in this node, a child 0 and 1, and we have a node car D. We're gonna have character D, data being D, 0 is gonna be null pointer, 1 null pointer. Next we're gonna have struct node and frequency here. But first of all, pretty much what this does is it defines a node structure that represents a character in the Huffman tree. Each of these nodes stores data pointer to its 0, and one of the child nodes constructor initializes um, these values that are there. We're moving on to node and frequency. Pretty much here we have the node sum node in frequency, node and frequency, node times n in frequency, and node and frequency here. And what this does is pretty much the structure of the node with its frequency, and it helps manage the nodes along with the frequencies that we get coming along into the priority queue. Uh, we're gonna have the compare nodes. This is structure. These are all structures, by the way, from starting in node frequency and going down. Um, so pretty much we have the compare nodes. It's pretty much a custom comparator. So it pretty much compares values, and this is for the priority queue. And this ensures that the node with the lowest frequency has the highest priority. And we put this in a min heap. So move on to the function declarations, and this is pretty much a lot. Got the unordered map, void print function map, priority queue, void print priority queue, and pretty much is we declare these here. So with how C++ works, the computer, you have some languages that go, you start up here and go straight down. With C++, you can just pick this out, bring it down here, and then bring it back into the main. So we can redeclare them first like here. And these are functions we're going to use in the program. Next we have the main function. Uh, this is just an entry point for the program, and it just creates a test string per se and prints a frequency map. It builds a frequency map, constructs priority queue, and then it prints a priority queue. Next we're gonna build a frequency map function. Um, so pretty much we have unordered map here. You pull the function that we have here, have it down here, and pretty much what it does is it creates and returns a frequency map for the input string. It iterates over each character um, in the string, updating the count in the unordered map. We use a for loop for this, reason being so it iterates the each character in the string, like I said. We go to print frequency map, void frequency, free, void frequency map, sorry. Um, and so pretty much this is just it just prints it out. Honestly, just we plug it in here and we print out the character and the frequency. We got peer first, peer second. We're just gonna figure out the frequencies, what character matches those frequencies, and it's gonna be printed out in this function right here. We have priority queue. Um, Pretty much what this does, it builds a priority queue from the frequency map, and it populates a frequency array from the unordered map. That iterates to the array to create nodes, and they push them into the priority queue. Um, and then we have our print priority queue, and it just prints out the contents of that priority queue, and it just pops the top element, which is the lowest frequency from the queue, and prints its character and the frequency, and from there just deletes the node so it doesn't have any memory leaks. So just pretty much that's what it does. It works just like a node tree per se. We declare value, we use an array. Um, we What we do is we add values into the tree, and then we go searching and etc. You find those values, least, most, and we print those out. So what I'm going to do is I am going to open a new terminal, show how this is done pretty much. Let's see, Control Shift. Okay, there we go. So we do this G++ dash O Huffman dot cpp, then dot forward slash no backward slash Huffman. Reason we have extra Huffman here is so we can uh the file, save the file there while we print out this one here. And here we go. So we have our character and the frequency it matches. That would be L2 O1 E1 H and 1. So there's pretty much how that matches up there. We also have our priority queue as well that we print out. Um, I think there's a bit of a typo here. Oh, so it's gonna be that right there. But right here we print out the numbers and their frequency. This one it just prints out the unordered map pretty much. So it's essentially almost the same thing, uh, just that we have each character paired with different frequencies. Other than this one, it's practically upside down. Um, as for this one, it's essentially the same thing. We have a LLM generated one, which I pretty much messed around with it, and then I adapted this one from this one over here. And so if I do this, it's just gonna do print out the priority queue. If I comment this out here, yeah, and then I put comments here, do that, move that, and I'm gonna run this again. So in terminal, um, C++, uh, C++, dash O, Huffman, file name, .cpp, and forward slash Huffman, and bam, we get the frequency map at the priority queue. So essentially it's the same thing, just that I did a different approach to this, which is, if you look at this, a for loop, um, uh, same, uh, almost a similar approach to the print frequency map. Just that was a bit shorter. Tried to condense it in these two, yeah, condense it a bit more, along with the priority queue, um, which is two for loops. In this case, I just have the node here. So just a different approach here, and it's essentially the same thing. Compress them, compress the characters here. So did a bit of research, and it's pretty interesting. Having a bit of fun messing around with this. So that would be